Hello everybody, Miss Collin here, and today we're going to talk about factoring trinomials when a is greater than 1. Okay, so we're going to go over some things called factor boxes. You'll see many different ways of how to factor on the internet. There are actually many different methods, so I'm going to post a couple of them, and I'm going to show you my favorite method throughout this video. That does not mean you have to use this box method. You can use a different box method. There's a couple different ways, but I'm going to show you the way that I think is easiest. Okay, so first things first, the number in front of x squared, if we think of our standard form here, we have ax squared plus bx plus c is a trinomial that we're given. Okay, and we're trying to factor it to get it into x blank times x blank, right? That's what we've been learning throughout this lesson. How do we factor from standard form into factored form? Okay, now originally in this unit, we started with factored form, if you remember, and we distributed into standard form. So we're kind of like doing a full circle here. Okay, we're going through from the beginning all the way around in a full circle. All right, so the number in front of our x squared here is called our a value. You'll hear me talk about the a value a lot. Okay, it's very important that you notice the a value when you're given a trinomial. All right, you also want to follow these steps. The first thing you want to ask yourself is there a GCF? Okay, if there is not a GCF, there's no GCF, and a equals 1, you don't need a box. Okay, no box needed. You can just use this method that we've been learning this whole time. Okay, if there is a number in front of a and there's no GCF, we got to make a box. Okay, so the first thing you're going to check as you're going through these problems is there a GCF? So here we have 6, 11, and 3. Okay, can we take something, the same number out of all three of these? Our goal is to try to make a equal to 1. No, I can't divide all of these by 6, right? So there's no GCF. Okay, so we can't use this method. We have to go to our box method here. Now, how we're going to set up our box method is we're going to have a here. We're going to extend this a little bit. We're going to have b down here. We're going to have c here. ABC. Okay, so you're going to do like a little diagonal there. ABC. All right, so I'm going to put 6x squared up here. B in this case is 11x. And c in this case is 3. Now, why I like this method so much is because it's kind of like you're doing a puzzle. Okay, so the first way you start your puzzle is going to be this way. Okay, you want to find two numbers that multiply to 6x squared and two numbers that multiply to 3. So that's how you're going to start it. Now, there's only two numbers that multiply to 3. That is 3 and 1. It doesn't matter where we put them in our boxes here. Okay, so always start with that. What is the one, it's a prime number. Start with your prime number there. Okay, however, 6 has more than two factors. Not only is it 6 and 1, but we also have 3 and 2 that multiply to 6x squared. Okay, what we can fill in here is we know that this will be x and this will be x, because x times x is x squared. So we're trying to multiply up right now. 3 times 1 is 3. Blank times blank will give me 6x squared. Okay, so let's just fill something in right now. Let's just say, okay, I don't know, 6 and 1. All right, make sure you are using a pencil for this. I cannot stress that enough, because you're going to have to erase. It's a puzzle. It's kind of like Sudoku. You got to think about it. You got to rearrange some numbers here. Okay, because my second thing that I'm going to do, my second part of this is across this way. Okay, I'm going to say, okay, I need to multiply across 6x times 3x is 18x, and 1x times 1 is x. And these numbers need to add to your total down there. Do these add to 11x? Absolutely not. That's 17x. So I need to rearrange my numbers. Okay, those don't work. It's a puzzle. We have to think. Okay, so it's not 6 and 1 that way. What if I did 6 and 1 this way? I'd have 3x plus 6x, because I'm multiplying x times 3 is 3x, 6x. 6x plus 3x is 9x. Nope, once again, not 11x. Okay, so let's try my other factors. Well, I know 3 and 2 are factors. So let's see, 3 and 2, 3 times 2 is 6x. Let's multiply these across. 3x times 3 is 9x. 2x times 1 is 2x. Does 9x plus 2x equal 11x? Yep, I've solved the puzzle. Okay. Now, how do we write this out, Miss Cullen? We have these boxes here, but doesn't really tell me anything, right? Okay, so what you have to do is you're going to take the cross values. So 2x plus 3 and 3x plus 1. And that's how you factor. Okay, now you might be a little overwhelmed at first and say, whoa, Miss Cullen, what just happened? This takes so much practice, you guys. Okay, this is going to come up again in Algebra 2. This is going to come up in geometry. This is going to come up in every math class you ever take. Okay, so you need to practice this. Okay, but once you do, it kind of becomes fun. All right, so I'm going to do a couple more with you. Don't you worry. All right, so let's start on this one. Is there a GCF is my first question. Can I divide all these by 2? No, 13 doesn't divide by 2. Okay, so then I need to set up my factor box. So I'm going to set up 2x squared, 13x down here, and negative 24 up here. Okay, remember, I'm starting this way first. I'm trying to find two numbers that multiply to 2x squared and two that multiply to negative 24. So let's start with my prime numbers. I know this has to be 2 and 1. That's the only way to get 2. Okay, and it's x and x. When it comes to negative 24, I have a lot of different options here. Maybe you even want to list them out to the side. I know 12 times 2 gives me 24. I know 6 times 4. I know 8 times 3. Okay, all of these give me 24. Okay, one of them is going to have to be negative because it's negative. Okay, and I want these two numbers that are going to add to 13x. All right, now it's not just as simple. This is why it changes with this a equals 1. It's not just as simple as finding two numbers here, right? None of these do. We have this a we have to think about too. All right, so I'm going to try these numbers out. Let's try some things out here. Okay, now you can also do this. You can also write in here and kind of test them out if you don't want to. So let's see, 12 and 2, would that work? That's 24 and 2. No, that doesn't add to 13. All right, let's try another one. What about 4 and 6? 4 times 2, that's 8x. 6, so 8x plus 6x. That's close, 14x, but not 13. Nope. Okay, all right, let's keep going. What about 8 and 3? Oh, and you could reverse those too. What about 6 and 4? So you might have to write over in 12x and 4x. Nope. Okay. You might feel a little lost at this point, but keep going. Keep just trying different numbers. Guess and check here. 8 and 3. 8 times 2, that's 16x and 3x. Could I get 13x that way? Whoa. Yes, I could. How could I get 13x that way? Well, I'd have to subtract 3x, right? This would have to be subtraction, which means this here is subtraction because I'm finding two numbers that multiply to negative 24. Once I have unlocked the code and I got two numbers that equal 13x, cross multiply, 2x minus 3 times x plus 8, and there you go. You factored it. How can I check if I did this right, Miss Cullen? Well, we can distribute. I have 2x squared plus 16x minus 3x minus 24. So you can check every single one of these problems. 16x minus 3x, that equals 13x. That equals my original problem. Okay. Okay, so that's box method number 1. Okay, that's what I find the easiest, but I'm going to show you another method here if you just feel like, Miss Cullen, do not understand that. I do not think I will ever understand that. Okay, so I'm going to show you another box method number 2. Okay, so I'm going to call it. So here's what you're going to do. First off, do I have a GCF? No. So I'm going to have to use some form of box method 1 or now box method 2. Now, box method 2 kind of goes with what we were doing before. We can use this x over here, okay? But when we set this up, it's a little bit different. Before, when we set it up, we would find two things that multiply to C and add to B, right? But now we have to include our A. So we have to find two things that multiply to AC and add to B. Okay, so AC is 2 times 3, that's 6. Okay, so we have to find two things that multiply to 6 and add to negative 5. Okay, well, 3 and 2 multiply to 6. How do I make it negative? Well, they both have to be negative. Okay, now, awesome. Some of you might be like, yeah, Miss Cullen, that's what we were doing before. Okay, but you can't just stop there. That's not your answer. It's not x minus 3, x minus 2. Okay, that's what it would be if we didn't have an a equals 1, but it's not. Now we have to kind of plug this in here into our box. Okay, and that's what's up here. Okay, we have our first term. If you scroll back up, first, outer, inner, last. Okay, and we're gonna take out the GCF and find the binomials. So here's what I'm going to do. I'm going to fill in the boxes here. My first term is 2x squared. My last term is 3. Okay, then I have my outer and my inner here. Negative 2x and negative 3x. It does not matter which goes where. I just set it up that way. Okay, now what you're going to do is you're going to take out the GCF of the rows and the columns. So let's start with the rows first. What is the GCF of 2x and negative 2x? That would be a 2x. Okay. Here, what is the GCF of negative 3x and 3? That would be a negative 3. We can take out a negative 3 there. Okay. Here's one of my binomials, 2x minus 3. Okay. Now I'm going to do it this way with my columns. What's the GCF of 2x squared minus 3x? What can I take out? I can only take out an x. What about negative 2x and 3? The only thing I can take out is a negative 1. That's x minus 1. Okay, so I have 2x minus 3 times x minus 1. All right, now I'm going to show you the other way. What if we wanted to do the other factor box? Okay, I'd set it up as 2x squared, negative 5x below, and 3 up there. ABC. Okay, I need to find two numbers that multiply to 2x squared. Okay, that's 2 and 1, x and x. And I need to find two numbers that multiply. That's only 3 and 1. Now you might have to test it around here. 3 and 1. Does 6x plus x give me negative 5x? No. Okay, so I know that's not right. Okay, what if I switched my 3 and my 1? What if I have 2x and 3x? Well, those give me 5x, but not negative 5x. How do I make it negative? Well, I know that negative 1 times negative 3 is positive 3. And if I multiply across, that would give me negative 2x and negative 3x. And negative 2x plus negative 3x is negative 5x. So there we go. Cross multiply. 2x minus 3 times x minus 1. Okay, so guess what? Either of these work, box method 1 or box method 2. Okay, I'll show you both on the next page. Flip the page. Now I'm going to go through these fairly quickly to make this video not too long, so just pause it whenever you need to pause it. Okay, our first step is, do we have a GCF? Here, x squared plus 6x. Do I have a GCF? Yeah, I do. It's x. So I'm going to take out the x, and I'm left with x plus 6. X times x plus 6 is as far as I can go. What about here? Do I have a GCF? Yes, it is 2. Okay, so I take out the 2. I have x minus 6. That's as far as I can go. Okay, those are binomials, not trinomials. So normally with binomials, you only have a GCF, and that's as far as you can go. Here I have a trinomial. My a is 1, which means all I have to do is go right here. I need to find two numbers that multiply to negative 14 and add to negative 5. Okay, if you think about it for a second, 7 times 2 is 14. How do I get negative 14? Well, I need a negative 5, which means this has to be negative 7, because negative 7 plus 2 is negative 5. If I did 7 minus 2, it would be positive 5. So I can write this as x minus 7 times x plus 2. And I'm done. Okay? Let's come to this one. This one's important. Okay? It's called dots, difference of the squares. Okay?